The most powerful caching mechanism that Gramex has is server-side caching. What this means is that Gramex will not do the calculations again and again when there is a request. It will calculate the results, whatever is the result of the microservice or the web page, store it, and then serve it the next time the same request comes. And you can control when to refresh and when not to refresh. So this can be done in the YAML configuration where every single handler or microservice accepts a cache key. And this cache key determines how exactly the caching works. This is what we're going to talk through now. So let's take a random number generator. What we'll do is take a pattern /random, which has this function handler that returns a random choice between A to J. Actually, let's type this out ourselves. We'll call this random, and the handler is a function handler, which has quargs, a function, which instead of being a random choice between these, let's say random.randint between 0 and 100. This is going to be at the pattern / let's say random. And now let's load the page /random. Okay, looks like I needed to restart Gramex. Okay, yeah. Now it's generating random numbers every time I reload the page. Great. Now let's add a cache :true to this. So we go here and add a cache :true. This is not under quargs. This is a top level parameter. So I'll just put it right at the top so you know where to add it. And if we have cache :true, now let's reload it once. It says 37. Now we'll keep reloading, but it still only says 37. That's because it's cached it and it's never ever going to regenerate it again. I could pick a different URL. I could say now change this to random2. And the first time I call random2, it gives me a random number, a new one. But thereafter, it's just cached it and will not change it. Now that's sometimes useful. If you want to create a response that's never going to change, but you still have to calculate it for the first time, this is useful. But if you want to change something based on certain parameters, then you can use a cache key. The cache key determines what we use to change the response or when we should rerun it. And one of the ways in which you can specify a cache key is by saying it's based on the request URI. That is, whatever is the URL. For the same URL, it will give the same response. But if the URL changes, it will give a different response. Now, how could the URL change? Well, if I put in a question mark x equals 1, question mark x is equal to 2, etc., we may not use these parameters. Or we could say question mark version equals 1, version equals 2. Now, for a given version, it's cached, but for the next version, it is no longer cached. So let's try that out. We'll say cache : key : request dot URI. Now, if we do this and go to random2 and reload, that's still cached. But if I say question mark, let's say version equals 2, that is now a different value. Every time I reload it, though, it stays the same. If I change it to version equals 3, then I get a new random number. Version equals 4, I get a new random number. So this is a way of applying versioning to caching where you can change it based only on the URI. Or we can change it just based on the path part. So that is, I want it cached only based on the URL itself here, not on the query parameters. When might that be useful? Well, let's say I have a random /dot*. That is, random /anything will give me a rand int from 0 to 100. So now I can say, let's say random /nothing, and that gives me a random number, which is always cached. Or I can do a random /2, and that is always cached. A random /3, and that is always cached. So in this case, the query parameters don't matter. Whether I say query x, let's say v is equal to 2, or v is equal to 3, that is not the only part that is used. It's also caching. Oh, sorry. Should have changed this to request.path. I forgot to do that. I was wondering why it was changing. If I change it to request.path, now if I say v equals 5, v equals 0, v equals 10, it doesn't matter. This doesn't change. I have to explicitly change this to 4 or 5 and only then it changes. So that's another way you can use the request.path. It can also be based on the request.query. So all the stuff after the question mark is what we cache based on. Or we can say only for a given remote IP address, I will maintain the cache. So every IP address gets a different cache response. Or I can say HTTP protocol is basically whether it's HTTP or HTTPS. For HTTP, I give a different response. For HTTPS, I give a different response. But other than that, it's all the same. Or a given host name, if we request it to, let's say, 6464.gramex.gramener.co, give me a certain response. But if I change it to 6565 or something, then it needs to be a different response. Or based on the HTTP method, get versus post. These are some of the ways you can use to cache. You can also combine these. Request.uri is nothing but request.path and request.query. But what you can do is specify these as multiple keys like this. It can be based on a request.uri and a request.path, which you can specify as making key as an array. The way you do that is, for example, you can either put it in an array in square brackets like this, request.uri, or you can make it an array by specifying it like this. It's not just the request that you can use. You can also use any HTTP header. So for example, you can cache it based on the content type. You can also cache it based on the URL query parameter. So basically, if you said args.v, let's say args.v here. So based on what is there in the question mark, in question mark v is equal to, it gets cached. Let's check that out. So I get a random number. This random number, if I say question mark v is equal to 3, gives me a different result. Question mark v is equal to 5 gives me a different result. But instead of 5, if I say 2, it still gives me the same result because it's caching based on question mark v is equal to 5. So that's what matters here. And if instead of v, I change it to, let's say, x, then it's no longer cached. X is equal to 5. If I reload, let's say for 6. Okay, that didn't work because v was effectively blank. So if I say v is equal to 3 here, then even if I change this to x is equal to 6, 8, and this part is 9, it doesn't change because all that matters is the v around it. Similarly, you can cache based on a specific cookie, or if the user is logged in, you can cache based on a specific user attribute. So user.id in particular is particularly useful. You can then say, I want this to be recomputed and be different for each user. So this is a structure where it says, I want it cached for a given URL for a given user. And that way, there will be a different cache that is maintained for every user and for every request. You can, in addition to this, specify an expiry. You can say, I want it cached only for 5 seconds or 10 seconds and so on. So let's add that. So we are caching based on the key args.v. And we have a 5-second expiry. So now if I reload this, no change. Okay, that has been 5 seconds. Oh, I should have removed the key. These are exclusive. So let's remove the expiry and reload. Okay, that's changed. Now I keep reloading. It doesn't change for 5 seconds, and now it changes. Every 5 seconds, the response will change. So that's another way you can control the cache. By default, the cache expires in 10 years if it's not specified, or when the cache store itself runs out of space. You can also specify what are the responses that you can cache for. So only HTTP 200 and 304 status codes are cached, which basically means when we are sending a response saying it's okay, or sending a response saying it's redirected to a different location. But supposing you want to cache, let's say, error pages. That is, if there is a response saying 404, page not found, or an internal server error, you could change the status and store it. This is pretty rare. You most likely want to leave the cache status at its default. Now, I mentioned earlier that the cache, if it could run out of space. Now, how exactly does this work? Well, by default, Gramex has an in-memory cache, and that is what is used. But you can choose your own cache types. That is done by adding a cache section. there are three types of caches that you can use: memory cache, disk cache, and redis cache. Memory caches are the default. Now, Gramex internally uses a half GB in memory cache. The cache is just called memory. And if it reaches the 500 MB limit, then the least recently used items are discarded. So it manages it fairly independently. If you want to change the size of this cache, then here's what you need to do. Copy paste this into your gramex.yaml, a cache section in which the memory cache, the name of this cache is important because we are overriding that cache. Type memory, make sure that this stays as it is, and change the size to whatever. If you want to reduce the cache size to reduce the memory, then just put in a lower number. If you want to increase the in-memory cache size, put in a higher number. This is in bytes. A second option is to use a disk cache. Disk caches are slower but bigger. So if you want to have something it's okay to fetch from the disk, because even though it's slower, the calculations are pretty extensive and you have a lot of data, then you would use a disk cache. But a disk cache is not as, but neither a disk cache nor a redis, sorry, nor a memory cache can be used if you have multiple instances across multiple machines. A memory cache can work only on the same process. A disk cache can at least be used across two Gramex instances within the same machine. But if you want to use Gramex instances across multiple machines, then you need to use a redis cache. For this, you need to set up Redis yourself and run it. That can be done by installing Redis from redis.io and pointing the cache to that. So the configuration for that looks like this. You say type :redis, path : localhost or whatever the server name is that you're running it in, port number, database number. And you can specify the size of the Redis cache. Similarly, for a disk cache, you say type :disk, and then the path. You can store the disk cache in any directory, and this is the size of the disk cache. Now, even though you specify these caches, they may not be used by default unless you mark them as the default cache. So for that, you specify default : false to say don't use this as the default cache, and default : true in another cache. So you can specify different caches and pick one of those to be the default cache, and that's what's going to get used. Now, one other thing that you must remember is that in-memory caches just store the data as a Python object. But if you use a disk cache or a redis cache, they pickle the Python objects. Now, if the object cannot be pickled, the cache will not store it. This is not something that normally affects anything because the vast majority of the content that we cache, especially page responses, are in fact pickable. But just keep something in mind that if at any point you explicitly cache something that is not pickable, then you need a memory cache for that. In case you want to programmatically access the cache, the way to do that is in your, let's say, function handler or any other piece of code, from Gramex, import service. And then service has an attribute called cache, which is actually a dictionary. And this dictionary will have the name of your cache, which could be something like different memory cache or memory. And then within that, it's a key value store. So if all the objects that are stored can be used here, and it also accepts an expire. Whenever you set the value, you can either say cache of key equals value, which will store it, or you can say cache.set of key with a value and an expiry, and that will store it with a duration specified by the expiry key here.